Okay, since I was feeling that um, I wasn't properly and fully understand section 3.2 of the book, and since I think that this is that section represents a sort of conceptual upgrade, I went through the section 3.2 again and tried to summarize uh, what are the main concepts and the main takeaways of that section. So everything is summarized in this markdown file that will push to GitHub, to the repository of structure and interpretation of computer programs, where you can also find slides and exercises. So let's start. So before chapter 3, we could think of evaluation as substitution, right? So in chapter 1, the substitution model was introduced. So for example, um, this procedure, square x, we could simply replace x with 5 and obtain star 5 5, and everything works fine. But it works fine because in this case, in the substitution model, variables are just names for values. However, in chapter 3, a new keyword has been introduced. That keyword is set, which basically introduces the concept of assignment. And when a programming language uses assignments, a variable is no longer just a name that can be replaced, but it's more like a named place where a value is stored. And that's the reason why the book introduces these two new concepts, environments and frames. Let's make let's give a definition of these two terms. A frame is simply a table of names and values. So for example, the global frame might contain x, which is associated to the value 10, square, which is a procedure, and plus, which is the primitive addition procedure. And an environment instead is a chain of frames. So instead of saying what does x mean, Scheme asks something like, starting from the current frame, where is the first binding for x? So where is the first time where x is associated to a value? And that is all an environment is, a context used to look up names. So imagine the program define x10 and define add xy. So basically, what this code is doing is assigning the value 10 to x, and then define a procedure add x that takes one parameter y as argument and simply do the addition between x and y. So if you call this add x5, you obtain 10 plus 5, so 15. So in this case, in this program, in this simple program, in the global frame, we have x, which is associated to the value 10, and add x, which is a procedure. However, the procedure add x is not just code. In the environment model, a procedure is a code plus a pointer to the environment where it was created. So add x is something like the list of parameters, the body of the lambda expression, the body of the procedure, and the pointer to the environment where the procedure itself was created. So in this case, the global environment. And when we call at x5, Scheme creates a new frame for that call. So you are creates a new frame for that call where there is this binding. So y is bounded to the value 5. And that frame points back to the environment saved inside the procedure, which is the global environment. So during the call, the environment looks like this. We are in the call frame where there is this binding, y, which is associated to the value 5, and the enclosing environment, which is the global environment, contains information about x, which is bounded to the variable 10, the value 10, and add x, which is a procedure. So now Scheme can evaluate plus xy, and what it does, it looks for y, finds it in the call frame, and the value is 5. Then it looks for x, but it's not present in the call frame, so it follows the pointer to the global frame and finds that x is equal to 10. So the result is 15. The important thing is that every procedure call creates a fresh frame. So if we let's use this example. If we defined a square procedure and then we call first square 5 and then square 10, the first call creates a frame where the variable x is bounded to the value 5, but the second call creates a different frame where x is equal to 10. So same variable name, but different frames and different calls. And that is how local variables stay separate. This also explains shadowing. So for example, let's look at this code. We define x equal to 100. Then we define that ftx is equal to x plus 1. But when we call f5, inside the call to f, there is a local frame where x is bound to the value 5. So, and the global frame instead has x equal to 100. But the lookup for the binding starts in the current frame. So inside f, x means 5, not 100. So we can say that the local x shadows the global x. Now the big reason this model matters is closures. Consider this example. We define make other x with this lambda expression. Then we define add 5 that takes this make other and passes the parameter 5. And finally we call add 5 3. And this is where the substitution model starts to feel weak and a bit inappropriate, but the environment model make it clear. So when we call make other 5, Scheme creates a new frame where x is equal to 5, right? X is the parameter, is the argument of the procedure, the lambda expression make other, and here we are passing 5 as argument. So when we call make other 5, the scheme creates a new frame where x is bounded to 5. Inside that frame, it evaluates the lambda expression, and that creates a procedure. But the procedure remembers the environment where it was created. You remember? Remember that the procedure is not just code, but it's code plus a pointer to the environment where the procedure has been created. So add 5 becomes parameters y, body, the body of the lambda expression, and the environment is the frame where x is equal to 5, right? So later, when we call add 5 3, scheme creates a new frame where y is 3, right? The parameter, the argument. And that frame points to the saved environment where x was bounded to the variable 5. So when there is plus xy, it becomes plus 5 3, and the result is 8. And this is the heart, the core of section 3.2. So that a procedure carries its birthplace, we can say, with it. And this is why functions can remember variables from the context where they were created. I also add this example when we use a set. So let's define a counter. When we define the counter, a new frame is created where n is bounded to 0, and the returned lambda remembers that frame. Then in this case, C finds n, changes it to 1, and returns 1. See, no, with this line, set n which is equal to n plus 1, okay, this one. And if you call it again, find the same n in the same frame, changes it to 2 and returns 2. So the frame is not just temporary substitution text, but it is a real place where state can live. And that is why chapter 3 needs the environment model, because with assignment and local state, variables are not merely names for values. They are names for storage locations inside frames. So the simplest mental model that you can use is that a frame is just a table of variable bindings. An environment is a linked chain of frames. A variable lookup searches in the current frame first, then follows the chain outward. A procedure is code plus the environment where it was created, and calling a procedure creates a new frame for its parameters. Define adds a binding to the current frame, and set finds an existing binding and changes the value stored there. Now, the important thing is that the environments explain both local variables and memory. A procedure call creates a local world, a closure keeps part of that world alive. So, if in chapter 1 you asked what expression does this reduce to with the substitution model, in chapter 3 there is a conceptual upgrade, because you can ask in which environment is this expression evaluated. And that's all for section 3.2. I think that this follow-up video was due, because I don't want to go ahead with the reading of the book without everything, without understanding everything. or at least without deep holes in the conceptual understanding of the book. So that's really all for today. See you in the next one. Ciao ciao.